Good morning, everybody. Today we're going to be going over law of cosines, which is the last of our laws of sines or cosines. Luckily for this one, there's no ambiguous case, so we'll just dive right into it. Law of cosines is super helpful when we know at least two of the sides, where we have side angle side or side side side. With law of sines, we could use it with when we had known two angles or the side side angle conundrum, which we talked about in the last video, which was the ambiguous case. But with these two known sides, or when you know two sides at least, except for the side-side angle, you're able to use law of cosines. Honestly, I don't remember all three of these versions. It's basically the same thing, but the important thing to know is that the side that you're solving for is going to be on the left-hand side, and the angle that is corresponding with that side goes in the angle. Other than that, it's a squared plus b squared. If you look at just this part, you're looking at the Pythagorean theorem, but that is specific to when we're working with a 90-degree angle. Cosine of 90 is 0, so this part just goes away when we're working with a right triangle. When it's not a right triangle, you have this portion to remember, so that minus 2ab cosine of that corresponding angle. It's also important to notice if you are working for side, 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 you don't know the angle, right? You only know the three sides, so you will eventually have to solve for that angle, whatever one you're working with. But the setup is like this. So working into the problems, just the fact that we know the angle, chances are this is going to be side angle side. So let's make our triangle and confirm that. We have alpha opposite to A, B is opposite to beta, and then chi is opposite to C. So side angle side, we have a case where we can use law of cosines. We are solving for A for the first time. Once we have a pair of angle and side, then we can start using law of sines. But to get one of those angles, or to get the pair, in which case we're missing the side, we need to use law of cosines. So a squared is equal to b squared plus c squared minus 2, 3, 4 cosine 30. Nice part about this is it's already solved. We just have to take the square root. You don't have to worry about plus or minus because we're dealing with the triangles, and triangles don't have negative side lengths. Really nice part, when we start moving away from unicircles, we don't have to worry about negatives because they don't really belong in the situation. That's 9, 16, 2 times 3 times 4 is 24, cosine 30, and we're taking the square root of this. Really, you're going to be using a calculator on this, but I'm going to simplify it a little bit more. 9 plus 16 is 25. Cosine 30 is root 3 over 2. 24 over 2 would be 12, so this is the same thing as 12 root 3. And you're going to take the square, or you're going to actually type that in your calculator, and you get about 2.05. I'm going to use 2.05 as my number I say, but remember, use the entire decimal from your calculator. Don't approximate until the very end. All right, working through the rest. Now that we have a pair and we're working with the acute angle, we're not going to have the ambiguous case. Also, we're working with side angle side, or yeah, so we don't have to worry about the ambiguous case here. We only have one possible triangle with side, side, side. So we're going to go sine of 30, and it doesn't matter which one you pick from here, just pick the number you like. I worked with 3, So I'm going to use beta. I'm going to be solving for beta. And again, air quotes, 2.05. Use the entire decimal. I'm going to multiply by that 3 to get it in the numerator. And then I'm going to take the inverse sine of this, kind of in one step. So beta is that. If you go through and type that in your calculator, you should get that beta is about 46.9. And from here we can solve for chi. It's 180 minus 46.9 minus 30. You should get that it's 103.1. Go back and label your triangle, but essentially that's it. So using law of cosines to find that missing side, then you have a pair to use your law of sines. This is it's definitely a more robust equation, so I wouldn't want to use this more than I have to. Usually you just have to use it once, and that should do the trick. Beyond that, you can use law of sines, which has a lot of repetitive steps to it, but it's at least a little bit simpler in the solve. All right, same idea. We have side angle side, so we're allowed to use law of cosines here. We don't have any pairs of angles and sides, so we're not able to use law of sines. That's basically the trick to this, identifying which one to use. If you don't have any pairs, you can't use law of sines because you're not going to be able to isolate one of the variables. So now we're stuck using law of cosines. So c squared is equal to a squared plus b squared minus 2ab cosine 60. That's a 60. Sorry, it's off. So c is the square root of all this. 4 plus 9 minus 12 cosine 60. Cosine 60 is 1/2. So we have that c is 13 minus 6, or root 7. Put that there. And now we have a pair of side and angles. We can use law of sines to get either alpha or beta. You pick. I'm going to go with, I solved for alpha the first time, so I'm going to do that again. Sine of alpha over 2 is equal to sine of 60 over root 7. And then solving for alpha, you're going to multiply by 2 and then take the inverse sine. And you're going to type that in your calculator. You get that it's about 38.2. Nope, I am looking at the wrong one. You get that it is about 40.9. Crisis averted. 40.9. And then finding beta, you're going to take the two angles that you know and subtract it from 180. That's 100.9, so that should be 79.1. And that is technically about. Okay, so again, label your triangle, you're done with that one. No real tricks here. Very similar to the unambiguous cases of sine, laws of sine. You just have to go through the motions and get all of them. We don't have a known angle here, so this is the first case of side, side, side. It should be the same process, except now you have to solve for the angle, which just adds a little extra steps to it. But I go with the obtuse angle, that way I don't have to even think about the, or the potential obtuse, so I'm going to go with the biggest side. That way I don't have to have any thoughts of the ambiguous case of sine, laws of sine. It shouldn't come up, but that's just, it eases my mind if I don't have to worry about it. Also, sidetrack, Law of cosines doesn't have that ambiguous case because we get the full range of 0 to 180 with inverse cosine. Inverse sine, we don't. We get negative 90 to 90. So the fact that if this was a negative, which you shouldn't come up with, but we don't get those obtuse angles over here. Cosine covers that, so we don't have to worry about the ambiguous case with cosine. Just a heads up. But whenever you're given a scenario where law of cosines is possible, you don't have to worry about ambiguity at all. So that's one of the best things about law of cosines. But again, I'm going to go for the biggest angle just to ease my mind, and we're going to plug in all of our sides. So c squared is equal to a squared plus b squared minus 2ab cosine, and we're going to solve for that. So 36 minus 16 minus 9, and then negative, that's 8, 24, divided by negative 24. Well, let's do this first. So that's negative 25. 36 minus 25. Uh-oh. I screwed up on my key, so I will have to do this calculation in front of you. That is 11. I put 9 on my key. That's fun. Divided by negative 24 is equal to cosine. Take the inverse cosine. And this is a case where it's going to be obtuse because we have a negative cosine, and it's just going to give it to us. That's the best part about this whole thing. You can see I used negative 9, not negative 11. So let's go inverse cosine of negative 11 24ths, which is 117.3. And then we are working to get, I went with alpha, but let's do the alpha. So sine of alpha over 4 is equal to sine of air quotes 117.3. I'm going to be using that gross decimal when I'm doing this. And we have c, which is 6. Solving for this, we're going to multiply by 6. Nope, we'll multiply by 4. Multiply by 4 and take the inverse sine. Inverse sine of that. Go into the calculator. Alright, inverse sine of 4 sine 117 point gross divided by 6 equals 36.3. So alpha is about perfect squiggly equal sign. 36.3, and then we're going to take 180 and subtract our two angles. Again, I am not approximating. I'm writing the approximate on here, but I am not going to approximate until I type it from my calculator. So we're going to take 180, move that over. 180, nope. All right, 180 minus, bam, and we get that it is about 26.4. Okay, again, label your triangles, but we have our 3 angles found. And just a quick check, make sure that they match up with the side ratios. B should be the smallest, A should be the middle, C should be the biggest. So let's just check. B is the smallest, A is the medium, and C is the biggest. So it at least matches up with the order of the sides. But other than that, it's kind of hard to check to see if you're right or wrong. But there we have it. Okay, we are done with the law of cosines, and we're going to start moving into some seemingly random lessons from here. So stay tuned, but we're going to get into our little grab bag section, which means that we're nearing the end of trig. So that's cool, but stay tuned until next time.